Hello everyone. In the previous class, we are discussing about descriptive statistics. In descriptive statistics, we have divided into two types, which is measure of central tendency and another one is measure of dispersion. In case of measure of central tendency, there are mean, median, mode and percentile. We have studied the first three, mean, median and mode, and now we will start with percentile. And in case of measure of dispersion, there would be range, interquartile range, variance, standard deviation, coefficient of variance, skewness, kurtosis. Before starting with percentile, I would like to recap about the parametric and non-parametric tests. Basically, parametric tests are those which follow Gaussian distribution, that is a bell-shaped curve, and it is affected by outliers. So in this we have discussed that previously we have discussed that mean is affected by outliers and it follows Gaussian distribution, so it must be a parametric test, whereas median and mode are not affected by outliers and they do not follow Gaussian distribution, so they both are non-parametric tests. Finally, now we will start with percentile. Percentile is basically the percentage of number which fall below that number. Like suppose in case of various exams like GATE, we used to say that this person has 82 percentile. That means 82% of people are scoring below his marks, whereas 18% of people are scoring above his marks. If we will say 50th percentile, that means 50% of students are scoring below that marks and 50% are scoring above that mark. So basically 50th percentile is the median. Median means the middlemost value, that is 50% things are below that and 50% things are above that. So median is 50th percentile. Next, we will study the formula of percentile. Percentile formula is basically P by 100 into 1 plus N. It will tell us the rank. Like suppose we want to calculate 80th percentile of a group of data. Suppose we have the data like 1, 5, 9, 2, 3, 8, 2. As we have said that percentile is basically how much percentage of numbers are below that number and how much percentage of number are above that number. So similarly, like median, the first step would be arranging the data in ascending order. Then only we can tell that that much of number are above that and below that. So our first step would be arranging in ascending order. So it would be 1, 2, 2, 3, 5, 8 and 9. So here n, the number of observations would be, it would be 7. So if we want to calculate 80th percentile of this number, we will put 80 upon 100 into 1 plus 7. N would be number of observation. So it comes out to be 0.8 into 8. 8 8 is 64. So that means 6.4th term would be our 80th percentile. So we have to first, the main step in percentile is that we have to adjust it to the nearest half rank. Like 6.4th nearest half rank would be 6.5. If suppose we have got the answer 6.1, so nearest half rank would be 6. If we have obtained 6.6, then the nearest half rank would be 6.6. Like suppose if we have obtained 6.8, then the nearest half rank would be 7. So here we have obtained 6.4 percentage. So we will round it up to 6.5. So 6.5th term would be our 80th percentile. Here 1, 2, 3, 4, 5, 6 and 7. So 6.5th would be average of 6 and 7 term. So average of 6 and 7 term would be 8 plus 9 divided by 2 is 17 by 2, which comes out to be 8.5. So 8.5 would be our 80th percentile. So 8.5 is the term whose 80% of numbers are below this number and 20% of number are above this number. So this would be percentile. Next we will start with measure of measure of dispersion. So measure of no one more thing, there would be a term upper quartile and lower quartile. So what is basically upper quartile and lower quartile? Upper quartile is 75th percentile and lower quartile will be 25th percentile. So lower quartile will be also called as first quartile and 50th percentile will be called as second percentile and 75th percentile is called as third percentile. So if someone tell us find the upper quartile, it is called as third quartile. And if we will call if someone call us lower quartile, then it would be first 25th quartile. So lower quartile is also represented by Q1. 50th percentile, that is median or second quartile, is represented by Q2 and upper quartile is represented by Q3. One more thing, that if someone tell us find the decile means 10th percentile. So if we will calculate this, this would be 10 divided by 100, 1 plus n. If someone tell us first quartile, it would be 25 divided by 100, 1 plus n. Second quartile would be 50 divided by 100, 1 plus n. This would be similar to our median. So we can calculate our median with the help of this formula also. And if someone tell us to find out third quartile, then it would be 75, 100, 1 plus n. So by calculating these values, we will get the rank, like which number we have to take. These all come under quartile. So next we will start with the measure of central dispersion. We have completed all the measure of central tendency. Central tendency are basically point estimate. A particular number we are saying which is a point, middlemost, like something middlemost value. So in that we have covered mean, median, mode and percentile. Now we will start with measure of dispersion, which is also called as interval estimates. So first thing what we would have to study is the range. So what is the range? Range is maximum number minus minimum number. Like suppose we have data 1, 3, 9, 15, 19 and 20. So the maximum number would be 20 and minimum number would be 1. So we will calculate 20 minus 1, which comes out to be 19. So 19 must be our range. And one more thing that we have left in percentile is whether it is a parametric test or a non-parametric test. Like median, percentile would also be a non-parametric test because it is not much affected by outliers. This would be same as we have discussed in median. Next, this is a range. First one is range of in measure of dispersion. In measure of dispersion, second one would be interquartile range. Interquartile range. Earlier one was just range. It is interquartile range. Interquartile range is basically we will first calculate the 75th percentile. What is the number which is 75th percentile? And then we will calculate what is the number which is 25th percentile. So in spite of calculating the difference of highest and lowest number, we will calculate the difference of 75th percentile minus 25th percentile. Then this will give us the interquartile range. Let's take an example. If we have the data 1, 2, 3, 7, 9, 15 and 14. So here remember one thing, the most important thing which you should never forget is arranging the data in the ascending order. So for calculating percentile and median, we have to first arrange the data in ascending order. So it would be 1, 2, 3, 7, 9, 14 and 15. So n would be 1, 2, 3, 4, 5, 6, 7. N would be 7. So for calculating the 75th percentile, similar 75 divided by 100, 1 plus 7. So it is 8 and 0.75. So 0.75 into 8 is 5. 5 it's 40. 7, 7 it's a 56. 60. So it comes out to be sixth term. So 75th percentile would be R 14. Similarly, for 25th percentile, 25th divided by 100 into 1 plus 7, which comes out to be 0.25 multiplied by 8. 2. So second term would be our 25th percentile. So 14 would be 75th percentile. So 14 would be 75th percentile and second term. And second term, that is our 2 would be 25th. So 14 minus 2, this is 12. So 12 is our interquartile range. Hope you all are clear with this. Next we will come to our next measure of central tendency, that would be sample variance and standard deviation. So first we will see standard deviation and then we will calculate variance. So standard deviation is basically how much our sample is deviating from the mean. Like suppose if someone has told us that our mean would be 10 and our standard deviation is 2. This means that our data is mostly lying between plus minus 2 of mean, that is 10 plus minus 2, which is 8 to 12. This is our standard deviation, that how much our data would lie in this value. So standard deviation will tell us how much deviation the values are carrying from the mean. So the formula would be this. This is the theoretical concept about the meaning of standard deviation. So now we will study the formula of standard deviation. Standard deviation is equal to under root sum of x minus x bar square divided by n minus 1. If our n is very large, that is, it is more than 30, we usually take it as n. But if our n is less than 30, we will usually take it as n minus 1. This n minus 1 is called as degree of freedom. Degree of freedom. So basically, what is this x minus x bar? X bar is our mean and x is our individual values. So we have to calculate the deviation of individual value from our mean and then squaring it off. So before taking an example, we will first discuss that whether standard deviation is a parametric or non-parametric. It should definitely would be a parametric test. Why? Because standard deviation is around the mean, and we have discussed that mean is a parametric test, so standard deviation would also be a parametric test. Next, we will take an example. Suppose we have the data 1, 2, 5, 9 and 10. These are our numbers. So we will first calculate x bar. Which means mean. Mean would be 10 plus 9 plus 5 plus 2 plus 1 divided by number of terms 1, 2, 3, 4, 5. So it comes out to be 10, 20, 25, 27 divided by 5, 5.4 is our mean. So what we will do is that we will do x minus x bar. So 1 minus 5.4, 1 minus 5.4 would be minus 4.4. 2 minus 5.4 would be minus 3.4. 5 minus 5.4 would be minus 0.4. 9 minus 5.4 would be 3.6, and 10 minus 5.4 would be 4.6. So if we will calculate the sum of all these numbers, this will come out to be 4 plus 8, 12, 12.6 and 13. 13.2 would be positive, and no, 4, 5, 6, 7, 7, 8, 7, 7.6 and 8.2 would be positive, and 4, 7, 8.2 would be negative. So sum of this x minus x bar would be 0. It will always come out to be 0. So if we will take sigma x minus x bar in our formula, that will definitely come out to be 0. So our standard deviation would be anyhow come out to be 0. So for avoiding that, our formula is sigma x minus x bar ka square divided by n minus 1. So here we are squaring it. So squaring it will convert all the values into positive. 4, 4.4, 4.4 square, 3.4 square, zero point 0.4 square, 3.6 square and 4.6 square. So all the values comes out to be positive. So we will calculate all these squares, then sum it off and apply it in this formula, and finally we will root it. Why we will root here? Rooting would Why we are rooting it? This is because by providing a root, we will nullify the effect that we have done by adding it, by squaring it. So squaring and rooting, the effect would be nullified. But if we haven't done squaring of our value, definitely our answer would be 0. So as to get an appropriate answer, we square it. And then to neglect the effect of square, we have done a square root. So this would be the formula of standard deviation. Next would be our next would be our variance. Variance is nothing, it is just square of standard deviation. So the formula would be sigma x minus x bar ka square divided by n minus 1. Because in case of standard deviation it is sigma, it is under root, and we have, in case of variance we have square it. So when we will square it, the square and under root, both effects will be deleted. So this would be our formula for variance. Hope it is clear. Next, one more thing that so finally also variance is dependent upon mean, so it is also a parametric test. Next, one more thing, that there would be a formula which is called as, there would be a formula, one more formula that we have left is basically this mode is equal to 3 median minus 2 mean. In some cases, when we have to find all the three values like mean, median, mode, then we will calculate any of the two values and finally calculate the third value with the help of this example, this equation. So this equation is an important equation which you should remember. And one more thing, that this equation is only valid in case of our Gaussian distribution. And Gaussian distribution is like this, like bell-shaped curve is our Gaussian distribution. So with this, so next we will study one more term which is standard error. Standard error. These are all the measure of dispersion. Standard error has a formula equal to standard deviation divided by root n, number of observations and standard deviation. So if we increase the number of our observation, our standard error would decrease. So this is the relation. But one more thing, standard deviation and number of observation are not related to each other, whereas standard error and a number of observation are inversely related to each other. One more thing, standard deviation basically quantify that how much our data is scattered from the mean, that how much the value varies from one another. Whereas standard error of mean quantifies how precisely we have determined the true mean, the true value of the mean. So standard error will tell us precision of our value, like the closeness of our value, and standard deviation will tell us scatterness of our value. And another thing, as we are dividing anything by standard deviation, so standard error of mean would always be less than standard deviation. So standard deviation would be more and standard of error of mean should be less. Next term is coefficient of variation. Coefficient of variation, CV, is basically depicted by standard deviation divided by our arithmetic mean, which is expressed in percentage into 100. This is the formula of coefficient of variation. This is basically, we will use this term to compare the variation in different group. Like if coefficient of variation is more for one group, that means if CV is more, if we are comparing two samples and one coefficient of variance would be 8 and another coefficient of variance would be 4, so that means if coefficient of variance is more, that means either standard deviation is more or mean is less. And if coefficient of variance is less, that means standard deviation is less or mean is more. So here, as coefficient of variance is directly proportional to standard deviation, the more the standard deviation, more scatter our data is. So our data is not of good quality. So we should have a lesser of coefficient of variation. So you should learn this formula. One more thing, that coefficient of variation depends upon standard deviation and arithmetic mean, and both of these values are basically parametric value. So our coefficient of variance would also be a parametric test. So just we will see once these notes. So standard deviation is sigma x minus x bar ka square divided by n minus 1, and it is only for Gaussian or normal distribution. As we have said that standard deviation depends upon mean, so it's a parametric test, so it's depend upon Gaussian or normal distribution. In case of variance, it is just the square of our sample. So it is the average of square of deviation about the sample mean. N minus 1 is called as degree of freedom, and n is so as we have said that n, if n is more than 30, we will take it if we'll take it as n, and if n is less than 30, we will take it as n minus 1. So in case of sample, usually size is less than 30, we will take it n minus 1, and for population, we will take it n. And this one, the next is standard error of mean. This is standard deviation tell us how scattered our data is, and standard error of mean is how precise our data is. So thank you.